Welcome to this lesson on shifting equilibrium. In chemical reactions that reach equilibrium, the system doesn't remain static when conditions change. Instead, the equilibrium position shifts in response to disturbances. Today, we'll explore how three key factors, concentration, temperature, and pressure, can cause equilibrium systems to shift and adjust their balance between reactants and products. The behavior of equilibrium systems is governed by Le Chatelier's principle, named after the French chemist Henri Louis Le Chatelier. This fundamental principle states that when a system at equilibrium is disturbed by a change in conditions, the system responds by shifting its equilibrium position to counteract that change. In other words, the system tries to restore balance by minimizing the effect of the disturbance. This principle is the key to predicting how equilibrium will respond to external changes. There are three main factors that can disturb a chemical equilibrium and cause it to shift. First is concentration, which involves adding or removing reactants or products from the system. Second is temperature, which affects the energy of the system and favors either the forward or reverse reaction. Third is pressure, which specifically affects reactions involving gases by changing the volume occupied by the system. Each of these factors influences equilibrium in a predictable way according to Le Chatelier's principle. Let's examine how concentration changes affect equilibrium. When you add more reactant to an equilibrium system, the system responds by shifting toward the products to consume the excess reactant. This shift continues until a new equilibrium is established. Conversely, when you add more product to the system, the equilibrium shifts toward the reactants to consume the excess product. Similarly, removing a substance causes the equilibrium to shift toward replacing what was removed. These shifts help the system maintain its equilibrium constant. Temperature changes have a unique effect on equilibrium because they influence the energy of the system. When you increase the temperature, you're adding heat energy to the system. The equilibrium responds by shifting in the endothermic direction, the direction that absorbs heat, to counteract the temperature increase. When you decrease the temperature, you're removing heat energy. The system shifts in the exothermic direction, the direction that releases heat, to replace the lost energy. Remember, endothermic reactions absorb heat, while exothermic reactions release heat. Here's an important distinction to understand. Temperature is the only factor among the three that actually changes the value of the equilibrium constant, represented by the letter K when you change the concentration of reactants or products, or when you change the pressure, the equilibrium position shifts, but the equilibrium constant K remains the same. However, changing temperature alters the fundamental balance between products and reactants, causing the equilibrium constant itself to change to a new value. Pressure changes specifically affect equilibrium reactions involving gases. When you increase the pressure on a gaseous system, typically by decreasing the volume, the equilibrium shifts toward the side with fewer moles of gas molecules. This shift reduces the total number of gas particles, which helps to relieve the pressure increase. When you decrease the pressure, by increasing the volume, the equilibrium shifts toward the side with more moles of gas molecules. If both sides have equal moles of gas, pressure changes have no effect on the equilibrium position. To summarize, equilibrium systems are dynamic and responsive. When subjected to stress through changes in concentration, temperature, or pressure, these systems don't simply accept the change. Instead, they actively shift their equilibrium position to minimize the disturbance and restore balance. Understanding Le Chatelier's principle allows chemists to predict and control equilibrium reactions, which is essential in industrial processes and laboratory work. Remember, equilibrium is not about being static. It's about being adaptable and maintaining balance through constant adjustment.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.